This presentation will be on hydraulic systems. Hydraulic systems work based on the theory of a mathematician, Pascal, who made note that the pressure of a liquid will distribute equal force upon equal areas. There are two types of hydraulic systems, open and closed. Open systems allow the liquid to move freely in and out of them, whereas a closed system contains the liquid and will reuse it. In an aircraft, we are going to find closed hydraulic systems. The systems in an airplane that are most likely to be seen using a hydraulic system include the brakes, flaps, and retractable landing gear. But the hydraulic system isn't limited to just those parts. It can also be found in a variety of other systems in an airplane. Each hydraulic system has six basic parts that are always going to be necessary. And those are the hydraulic fluid, the reservoir, the pump, the pressure control valve, fluid control valves, and actuators. So while there are some systems that have more than these six are kind of like the bare basic minimum parts that each hydraulic system is going to have. The reservoir is where hydraulic fluid is stored, and if there's ever any question about the quality of hydraulic fluid being used, it should be drained, flushed, and refilled. The reservoir for the hydraulic fluid must be able to hold a slightly greater volume than just the hydraulic fluid to account for expansion as temperature increases. The reservoir will also have the ability to release air from the fluid to make sure that there is no air entering the hydraulic systems. Different aircrafts may use either a pressurized or a non-pressurized reservoir. In smaller airplanes, the non-pressurized reservoir is going to be more common. The pump is another important one of those six basic parts of each hydraulic system. And so this will take power from either the engine or an electric source and work to move that hydraulic fluid and apply pressure to different parts of the system as directed. Pressure control valves are another important component, and these can either be a pressure regulator valve or a pressure relief valve. The pressure regulator valve senses pressure downstream from the pump, and if it exceeds a level that has been set by the manufacturer, it sets off a spring and a valve opens to recirculate the fluid outside of the pressure control area for reuse. The pressure relief valve is usually only used as a backup system, and if it senses that there is a higher than normal pressure, it will open a release valve. So fluid control valves help preserve fluid if there's a broken line, almost like the circuit breaker of the hydraulic system, where if one part of the system isn't working, it will keep that damage from affecting the rest of the system so that the other systems that are using the hydraulics are still able to function. The actuators are what gives the hydraulic system its power, and there are a few different types of actuators. One is the single acting actuator, which allows pressure from the hydraulic system to only be applied in one direction. And for it to be moved back into position, it's going to need a different mechanism, such as a spring. Another option would be the double acting actuator. And this allows the hydraulic system to move it in two different directions because it's able to apply pressure from both sides. So hydraulic fluid is the lifeblood of the hydraulic system. It's incredibly important for the aircraft. Not only does it move around the pressure as directed and cause reactions to move gears and operate different systems, it's also there to help lubricate the system and keep the airplane healthy. Hydraulic fluid needs to be able to withstand heat and be a little bit heat resistant since there can be a lot of friction within these hydraulic systems due to the moving liquid and different tubes and turns that the hydraulic system has. So the fluid needs to be able to withstand that heat and keep those parts cool as best it can. Another important feature of the hydraulic fluid is that it needs to be able to resist breaking down and be non-corrosive. so that it again just keeps parts of the airplane that it's always coming into contact with healthy. So some considerations when doing a pre-flight inspection, it's good to always look on the ground around the airplane to see if there is any hydraulic fluid. You can check the hydraulic fluid levels to make sure that they are where they are indicated that they need to be. And you can also double check that the right type of hydraulic fluid is being used based on the operating handbook. Another good pre-flight practice is while you're preparing to taxi, it's really important to double check those brakes to make sure that the hydraulic system is working properly. When doing preventative maintenance on the hydraulic system, there are four major causes for concern that a pilot needs to be aware of. One is water. If there's any water mixed in with the hydraulic fluid, this can produce acid, which will cause issues within the system and lead to corrosion. Another is air, which can cause oxidation of the hydraulic fluid. And then heat is another factor, which is going to cause the hydraulic fluid to degrade faster. And then dirt within the hydraulic fluid and in those lines could cause a lot of problems because hydraulic fluid is also being used as a lubricant throughout the system. So if there's any dirt or anything else, it's going to start acting like an abrasive. And that's why it's really important that if you suspect your hydraulic fluid has been contaminated, to drain it, flush it, and refill it. So some issues that you might run into with the hydraulic system, if you're moving controls and the way that you're supposed to be and the airplane is not responding, it could mean that there is a fluid leak and the hydraulic fluid is not getting to the actuator, or the fluid might just be returning right back to the reservoir, which could mean that there are bad seals or a relief valve is not functioning properly. If it's not one of those issues that's causing the problems, it's most likely mechanical failure. So if the pump is making a lot of noise, this could mean you have cavitation, which means that there are low pressure bubbles because of how the pump is rotating. And this could be caused if the temperatures are too low, if there's dirt, if there's any problems with the tubing, or if the fluid is too thick. This will cause the pump to move slower than it should be moving. Another problem is if the pump is drawing air, which is another possibility, and that means that there is just not enough hydraulic fluid in the system for it to be functioning properly. And this could be caused because of a leak in the tube or a bad seal. And those are the most likely culprits. There are other parts of the pump that can fail, but the most likely cause is going to be low fluid problems. Most problems with the hydraulic system can be avoided as long as the hydraulic fluid is being kept clean and at the levels that the airplane requires. So with the PA-44, one of the systems that uses hydraulics is the landing gear, which uses both hydraulic and electrical systems. Hydraulic pressure is electrically powered. There's a reversible hydraulic pump, and the hydraulic pump has a two-position gear selector, which is located on the left side of the control panel. The knob must be pulled out before it is moved into either the up or down positions. Extension or retraction takes around 6 or 7 seconds. If there is any failure with the landing gear hydraulics, the system will rely on gravity to hold the landing gear down and extend, or springs to propel it back upward and retract it. The brake system on the PA-44 also uses hydraulics to function. There is a brake system on each of the main gears, and to use them, you use the toe pedals mounted in the pilot and co-pilot seats. This system is independent of the hydraulic system used for the landing gear. The brake hydraulic system uses a petroleum-based hydraulic fluid, and this should be checked periodically and at minimum at every 50-hour inspection and refilled as necessary. There's a marking on the reservoir that indicates the necessary fuel levels. And that is my presentation on hydraulic systems. Thank you for watching.